Today we're going to learn about real numbers. And before we start talking about the definitions of different types of real numbers, I want you to look at the numbers that are on the following pages as we go through the video. And I want you to try to figure out which number does not belong. So let's go ahead and get started. Here's the first set of numbers. I want you to take a look at them. And then I want you to decide which number does not belong. Do the same thing with this list. Look at the numbers and decide which do not belong. Here's our next list. Which number do you think does not belong? Next. Same question. Which number does not belong, and how do you know? Here's another list of numbers. Which number does not belong? All right. All right, so you guys should have your notes in front of you, your foldable for your notebooks. And on this foldable, we're going to talk about the different types of real numbers. This is the real number system. So we're going to go through the different types. You have a flap that you should have cut that says irrational numbers. And on the other side of the flap, you're going to write the definition that we have here as we talk about it. So real numbers, when we have real numbers, first thing we decide is whether the number is irrational or rational. So let's first talk about what an irrational number is. An irrational number is a number that cannot be written as the quotient of two integers. So fractions are not irrational. The decimal form of an irrational number neither terminates nor does it repeat. Okay, so on that flap, I want you to think about what this is saying. It's telling you an irrational number is a number. It can't be written as the quotient of two integers, and it doesn't repeat. It neither repeats nor does it terminate, or vice versa. Okay, so let's think about what kind of numbers do not repeat or terminate. All fractions repeat. Whole numbers repeat. So let's think about numbers that neither repeat nor terminate. One number that doesn't repeat or terminate would be pi. You've probably learned that pi is a number that keeps on going. And if you have seen pi on the calculator, it does end, but that's only because the calculator only has so much room. Pi starts with 3.1415926, and it keeps going and going. So it's impossible to predict the next digit of the number unless you've memorized it, because it's an irrational number. So any number that keeps going and doesn't repeat is irrational. Repeating decimals like 0.5 with the bar on top, although it keeps going indefinitely with that 5, it does repeat, so it's rational. It's predictable. So think about if someone is behaving irrationally. When someone is behaving irrationally, we say that it doesn't make any sense. Their behavior is unpredictable. We don't know what they're going to do next. So remember that with irrational numbers. We don't know what number is going to come next. Therefore, they're irrational. So 0.5 repeating or 5/10 repeating is not irrational. So let's get, if you need to pause the video, go ahead and do that so that you can get this written down. But let's go ahead and think of another example that's irrational. Let's think of the number 5.63, and it keeps going. So if the number keeps going, there's no particular pattern to it, it doesn't repeat, again, that's going to be an irrational number. Now I want you guys to have a calculator, and with your calculator, I want you to find the square root of 16. So take your calculator and put in 16 and then press the square root key and see what you get. All right, when you find the square root of 16, you may already know that the answer is 4. 4 is not irrational because it terminates, it ends, or it repeats. But let's try another number that's not a perfect square. Let's think of a number that does not have a square root that's a whole number. So how about number 20? So put 20 in your calculator and press the square root key. Once you look at that number, you can see that the square root of 20 is equal to 4.47213, and it just keeps on going. So the square root of 20, although the square root of 16 is not irrational, the square root of 20 would be an irrational number, as well as pi. All right, so now that we've talked about what irrational numbers are and you've copied down your notes, let's talk about rational numbers. So if it's not irrational, that means the number is going to be rational. So rational is all of the other real numbers. It's fractions, it's numbers that repeat, it's numbers that end, it's whole numbers, it's positive and negative numbers. So this is our definition. A rational number is a number that can be written as a over b, so all fractions are rational. And b is not equal to 0 because we can't divide by 0. So for example, a rational number would be 1/3. That's rational. Also, 10 halves, right? 10 halves is a fraction. If we simplify it, we get 5. So 5 is also rational. Let's think of a square root. Square root of 25, right? Square root of 25 is 5, and 5 is a rational number because it can be written as a fraction, 5/1. Any number that can be written as a fraction is rational. So make sure you get this copied down. And then we'll talk about what type of numbers, what other specific categories can numbers be in. All right, so we started out with irrational numbers or rational. So if a number is rational, it can also have other names. So let's take a look. Integers, okay? So an integer, let's think about what that is. You guys learned about integers last year. We know integers are like -2, they're 7, they're 9, they're -500. These are all integers. So let's define integers. An integer is shown here. Integers are whole numbers and their opposites. Integers are rational. They can be written as fractions, right? Because 7 can be written as 7/1, 9 can be written as 9/1. You could just put 1 underneath here. You could also have -16/4. And that's an integer because it simplifies to a whole positive or negative number, -4. So these are all examples of integers. So numbers that are real, first we decide whether they're rational or irrational, and then we decide whether they're going to be integers. And if they are numbers that are whole numbers and their opposites, they are integers. The next category we're going to look at is whole numbers, okay? So we start with our number, and now we're thinking about whole numbers. Whole numbers only include positive numbers. So if you notice here, from the integers where we included our negative numbers, whole numbers do not include negative numbers. So here's an example. So whole numbers do not include negatives. So -5, it's the opposite of a whole number, but it's not a whole number because it's negative. 20/4 simplifies to 5, so it is a whole number. The square root of 36 simplifies to 6, so it is a whole number. The square root, or negative, the opposite of the square root of 16 is negative 4. A negative number is not a whole number, so it's not included. So in your notes, make sure that you write on the flap the numbers that are whole numbers, and then this little note here, whole numbers do not include negatives. All right, so let's say we have a number and we've determined that it's rational. It's an integer, like the number 5. Let's go forward and talk about, one other thing I want you guys to look at here. Whole numbers include 0. 0 is a whole number. That's really important. So let's take a look at our next definition. Now we have natural numbers. This is the most specific category for numbers. These are all otherwise known, aka counting numbers. All right, so let's take a look at what happened here. We had that list of -3, -2, -1, 0, 1, 2, 3, and then let's go back to that. We had the negatives, and then when we went down to look at whole numbers, we got rid of the negative numbers, but we included 0. And now for a number to be considered natural, look what happens. 0's gone. So natural numbers are the set of numbers that do not include 0, and there are counting numbers. So think about when you first learn how to count. If you're counting things, so for example, if I have these stars and you're learning how to count, you would start with 1, 2, 3, so on and so forth. You do not start counting with 0. It's not natural to count with 0. So natural numbers do not include 0, but whole positive numbers. All right, so now that we've learned the definition for all the different types of real numbers, let's look at how we will categorize them. So on the other page in your foldable, you have a diagram, a graphic organizer, and let's look at this. So just like we looked at in the slides, we first determine whether a number is rational or irrational. Okay, if a number is rational, it can also be an integer, a whole number, and a natural number. But if it's only rational, or if it's irrational, it can't be any of those things. So let's take a look at the list of numbers. Actually, what I'd like you to do is I want you to look at these numbers here, and I want you to use pencil in case you have to erase. And I want you to take these numbers and I want you to put them where you think they is the most specific category. Most specific. So go ahead and put the numbers where you think they belong, looking at the notes that you just took. So go ahead and pause the video and place the numbers where you think they belong. All right, let's see how you did. Okay. So, give me one second. So what you're going to do is you're going to take these numbers. So what we're going to do is we're going to place these numbers. You've placed them in pencil. Now let's talk about each of them. All right, let's start with this one here. We have 1.326 and it's ... So that means it keeps going. So let's think about where that one goes. All right, so this number here, let's think. Irrational numbers, they do not repeat or terminate. Okay, so let's start up here. Is it irrational or rational? All right, it should have been in the irrational category because it doesn't repeat, it doesn't terminate, it's unpredictable. Okay, let's look at the next number. We have the square root of 16. The square root of 16 we know is 4, and 4 is not irrational, it's rational, right? Because 4 is rational, it terminates or repeats. We can write it as a fraction, 4/1. It's also an integer. It's also a whole number. And now for the last category, we ask ourselves, is it a counting number? Do we count to 4? Yes, it is. So the square root of 16, the most specific category for the square root of 16 would be natural numbers. But I want you to think about this. The square root of 16 is rational, it's an integer, it's a whole number, but its most specific category is going to be natural. All right, let's take a look at negative 5. Negative 5, let's see, irrational or rational? That's the first thing we decide. All right, it's rational because it repeats or terminates. It's an integer because it's a negative whole number, but it's not a whole number. So we stop here. Remember, whole numbers only include positive numbers. Negative 1/2. First we decide, is it rational or irrational? That's right, it's rational because it's a fraction, but it's not an integer because an integer is whole numbers and their opposite. So you're going to put negative 1/2 there. Negative 8 is rational, and it's also an integer. 2/3, it can be written as a fraction. It is a fraction, so it's going to go in our rational category. 2 3/10 repeating. It does keep going, but it's predictable, so it's not irrational. It's rational. 0. Okay, let's look at 0. Let's see if you were paying attention earlier. Irrational or rational? It is rational. It could be written as a fraction. It is an integer. And it is a whole number. It is not a natural number because we do not count with 0. So it's going to go right here in our whole number category. Next, let's look at pi. Pi is one of those numbers that keeps going and you can't predict the next digit unless you've memorized. So pi is irrational. Next one, negative the square root of 169. So negative the square root of 169 is going to be negative 13. So it's negative 13. Okay, and negative 13 is a rational number. So since negative 13 is rational, it's rational, so it's negative 13. And negative 13 is also an integer. So it's going to go to the most specific category would be an integer. All right, next we have the square root of 50. So you have your calculator in front of you. Type in 50 and then click the square root key. And we can see that it's not a very predictable pattern. There's no pattern to the digits after the decimal point. So this is going to be an irrational number. Oops. And then our last one here is 12/3. 12 divided by 3 is 4. So we're going to put 12/3. It's rational, it's an integer, it's a whole number, and it's also a natural number because it simplifies. 12 over 3 simplifies to 4. All right, how'd you do? Now remember, if you didn't put them correctly, you could erase or you could use a pen to make corrections so that you have your numbers labeled correctly. All right, you have another paper that I've given you, and I want you to go through and using your notes, I want you to figure out which numbers are rational and which ones are irrational, integers, whole numbers, and natural numbers.